Okay, so the first thing that you might be asking yourself is, what is rationalizing? What does that term mean? And what it means is simplifying a fraction so that there are only rational numbers in the denominator. So we can only have rational numbers in the denominator. That means that there can be no irrational numbers in the denominator, or imaginary numbers. We don't want imaginary numbers in there as well. So let's look at examples of rational, irrational, imaginary, and complex would be part of imaginary. So here's some examples. Notice complex has a real part and an imaginary part, so it's in the form a plus bi. Okay, now why do we have to rationalize? This is a very common question. Why do we have to do this? Well, one answer is it's an accepted standard form, but it makes sense if you think of it as well. Let's look at 1 divided by square root of 2. Well, 1 divided by square root of 2, what's square root of 2? Well, the square root of 2 is a number that keeps on going on and on and on and on. It will go on forever. So how do you divide 1 by this number that goes on forever? Conceptually, it's kind of hard to grasp. So that's why we, instead of looking at it like this, we rationalize this. So really quickly, we're going to teach you this. But I multiply the bottom and the top by square root of 2, and that gives me the square root of 2 divided by 2. So now we can say, oh, what's the square root of 2 divided by 2? And that makes way more sense rationally. So if we look at this, we know the square root of 2 is a right triangle with sides of 1, and this side, using the Pythagorean theorem, would be square root of 2. Well, we can divide this in half and say that that is half of the square root of 2. Okay, let's look at an example problem here. So if you look at this, we have a square root in the denominator. So here are steps for rationalizing a fraction when there is a square root in the denominator. And it's very simple. What we do is we multiply the numerator and the denominator by the square root found in the denominator. So in this case, we are multiplying the top and the bottom by the square root of 15. Notice this doesn't change anything because this 15 over 15 is simply 1. That's just 1. You can multiply anything by 1 and it doesn't change. So if I multiply these, let's do this. Well, on the top, I'm going to do one thing first, and let's simplify this. This is the same as 3 times 4 times 5 times the square root of 15. And it's over the square root of 15 times the square root of 15. So these square roots are going to cancel each other out. Square root of 15 times the square root of 15. I'm just left with 15. Well, right here, the square root of 4, we know that that's 2. So I'm going to write that on the outside. And what I'm left with is a square root of 5 and a square root of 15. So let's write this as 5. I have that 5. And 15, I'm going to break this down in 5 times 5 times 3. Now note, I just said that 15 was 5 times 3, and I have this 5 left over. The 4, I took the square root of it and I made the 2 out here. Now, it's a little trick that if I write everything as their factors, well, look what happens. When I have a 5 and a 5, well, the definition of square root, that means that that's 25. The square root of 25 brings it out there. So that gives me 3 times 2 times 5. and I'm left with the square root of 3 over 15. Notice 3 times 5, if I clean this up a bit, 3 times 5 is 15, so those all cancel out. And my final answer is 2 square roots of 3 over 1, which I don't really have to write that 1, so it's just 2 square roots of 3. Now I did that fast, but if you have any questions, you can call me over on how I got to one of these steps. But my tip is, write it as factors. It's easier to see if you write all the factors out. Okay, let's do another example. Okay, so notice that we have a plus b, parenthesis a minus b. This is the special cases. When we have this form, and I FOIL this out or I distribute this out, I get a squared minus b squared. So we're going to use this in order to simplify these binomials. So it's binomial because we have two terms in both the numerator and the denominator. So let's look at this. So since this would be a plus b, what I want to multiply the top and the bottom by is a minus b. So the top and the bottom, a minus b. Okay, I have these now, so two sets of binomials. Now I need to FOIL them out. So on the top and on the bottom, I'm going to FOIL these. So let's do the bottom first. So if I FOIL this, I will get 5 times 5 is 25. 5 minus the square root of 5, or 5 times the negative square root of 5 is negative 5 square roots of 5. 5 times the positive square root of 5 is plus 5 square root of 5. And these will always cancel out. These middle terms will. And then I have 5, the square root of 5 times the square root of negative 5, which gives me negative 5. The two square roots cancel out. So I get negative 5. Alright, that's the first step in the denominator. Let's do the first step in the numerator now. 5 times 5 is 25. 5 times negative square root of 5 is negative 5 square roots of 5. Now up top I have square roots of 2 times 5, so that's plus 5 square roots of 2. And the final step, if I have square root of 2 times square root of negative 5, that gives me the square root of negative square root of 10. Alright, so now let's just simplify this and combine like terms. I have right here 25. Now I can't combine these are not like terms, so I'm just going to leave them. 5 square roots of 5 plus 5 square roots of 2 minus square roots of 10. These are all different terms here, so I cannot combine any of these. So they don't combine, because that's similar to saying that this would be an x, this is a y, and this is a z. Well, you can't combine x, y, and z. They're different things. They're not like terms. So we cannot combine them. In the bottom, though, we can't combine a lot because we're going to get a rational number. And the middle terms here, we can see that they cancel out. There's no more middle term. And I get 25 and minus 5. My answer on the bottom is 20. And this is my answer. Okay, now if you look here in your worksheet, some of the answers come out to be a little bit messy. This was number 16 on your worksheet. So as you see, they come out, that's just the answer. That's as simplified as we can get without writing it as a decimal. Okay, let's look at another example here. Okay, now we're getting into imaginary numbers. So we're going to use the fact that I is equal to the square root of negative 1, so therefore I squared is equal to square root of negative 1 times the square root of negative 1, which is equal to negative 1. So if I want to get rid of this I right here, all I have to do is multiply the top and the bottom by I. So if I do that, that gives me negative 5I on top. And on the bottom, I get negative 4I times I is I squared. So when I simplify that, when I clean that up, I get negative 4 times negative 1. Okay, so that equals the negatives cancel out, and I get 5I over 4. So for imaginary numbers, all you have to do is multiply I over I, and that gets the I out of the bottom. Alright, one last example problem. And this last one, in your notes, I want you guys to write down, we need to know the complex conjugate. So similar to what we did with the other square root, but if I have a plus bi, well then the complex conjugate is a minus bi. And you can see here, if you have an a plus bi, then the conjugate is a minus bi. If it's a minus bi, it's a plus bi. And that seems confusing right now, but I'm telling you, when you get the hang of it, it's not too bad. I have a minus bi right here. So what I'm going to do is I'm going to multiply 5. I'm going to change that minus to a plus. 10i. Now whatever I do to the bottom, I have to do to the top. I'm only multiplying this by 1, so I don't change that. And now I distribute this out. So it's a little bit of foiling, but that's okay. We know how to foil. So I'm going to show you how to do this, and if I go too fast, you can always just hit pause and try to find out what I did, and you can always call me over to your seat and I will help you. Let's go through this. Negative 1 times 5 is negative 5. Negative 1 times 10i is negative 10i. 7i times 5 is positive 35i. And 7i times 10i is positive 70i squared. Now we're going to be able to simplify that, but before we do that, let's write the denominator out. 5 times 5 is 25. 5 times 10i is positive 50i. Negative 10i times 5 is negative 50i. Negative 10i, positive 10 is positive 100. Sorry, that is negative. Negative 100i squared. Okay, let's get rid of that. Let's simplify this up now. So we're going to combine like terms. If you look at this, this and this are like terms. And we're also going to use the fact that I squared is equal to negative 1. So let's do that. We'll clean this up a bit. So the numerator, negative 5, negative 10i plus 35i becomes plus 25i. And I'm going to substitute in a negative 1 here, so that becomes negative 70. Now down here, we can see that 50i, these two terms are always going to cancel out. So on the bottom here, I have 25, and we'll do the same thing. Negative 100i squared becomes positive 100. Alright, let's go to the right of this now, and let's clean this up. We get, for my real part, negative 75 plus 25i. On the bottom, we get 125. Alright, now this is rationalized. However, it's not written in simplest form. We can go one more step. If you look at this, I really like things that are multiples of 25 because you can think of money. I have a quarter I here, 3/4 here, and a buck and a quarter here. Like you can see all of these you can divide out by 25. So if I divide everything by 25, well, there's 3 25s and 75. There's only 125 in that. And there's 5 25s and a buck and a quarter. There's 5 quarters and $1.25. I like to think in money. So this is my answer. and that's written simplified, and it's rational, which is our goal for today.